Hello, friends. A few weeks ago, I asked on Twitter, what do you guys want to learn more of in 2024 this year? And surprisingly, a lot of people wanted to learn more about decoding manually. So this relates to manually decoding event logs. So I have an example transaction here. Essentially, event logs are just events that are emitted in a transaction, right? That is related to each contract. So in this sample transaction, there are three event logs that are emitted. We have the across protocol event, the Li-Fi event, and also the rep Ethereum event. Now, if you didn't know, there's already a decoded event logs table on Flipside, and all this would be decoded very nicely. But for for whatever reason, let's say we do not have the API for the contract, or if you would like to decode it manually to verify if the decoding is true, you can do your own manual decoding, right? And that's what I'm gonna do a overview of today. So manual decoding is taking I guess for event logs, is taking topics and data and to be able to sort of like map them to their right data type, right? And so I'll just show you what that looks like in a bit. But as you can see here, topics and data are actually a bunch of hex data, right? It looks like this, all jumbled up, including topics. And I think Etherscan does a great job here of like being of tying back topics. What is topic 1, topic 2, topic 3, and you can use this to as information for you to decode. So let's get right into it. So I have a I have a query here on Flipside using the decoded event logs table, because we can first compare what is already being decoded to us manually decoding it, right? Okay, so the first step you want to do is you want to be able to read whatever is on here right here. So the words in green are data type, and the words in red are the variable names. And so if you look up data types Solidity, like if you Google that, you'll see a list of various data types. The most common ones that you encounter are these uint, or unsigned integer, which just means integers that are positive in value, right? There won't be any negative integers. And then the next common one would be address. Address here would be it's a string data type. It's an address, right? It's your typical 0x ABC address, right? So you see here there is a variable called origin token, assuming this is a token address, and it's of data type address. And then there is a recipient, right, of data type address. And amount, origin chain ID, all these are different. All these are integers, and the numbers here just represents the range of the size of the integer that it can hold. So don't have to worry too much about these numbers over there. Okay, so with that in mind, we can then another thing to know is if the data is in topic, it will be listed as topic. So in this case, Etherscan says index topic 1 destination chain ID. So if you look on the left here, topics, there is 0, 1, 2, 3, 4. And so index topic 1 refers to topic 1. And so this, when decoded, gives you the destination chain ID. Same thing with index topic 2 here, deposit ID. When decoded from hex to integer, it gives you deposit ID. And then timestamp, you have to do two conversions. One is from this hex value here to integer. So if I were to click on decode, this is in data, not in topics. I will get to this in a bit, but my point here is that if it's related to topic, there would be a topic before the data type. Okay, and so you might be wondering, what about amount, origin chain ID? Those do not have a topic in front of the data type, and all this which does not have topic will be under data. Right, it will be under the data field. So you would have amount, right? Amount, origin chain ID. This you would skip because this is in topic. Relayer fee percent, quote timestamp, right? Relayer fee percent, quote timestamp. And so all this would be combined together in the data field. And so let's first try to get topics 1, right? Topics 1 we know is destination chain ID. So let's go back to our query. And I've already written out here, select topics data from the decoder event logs table, filtered for the timestamp, the transaction hash, this transaction over here, and then specifically this event, which is funds deposited. You can also use the regular event logs table and just filter for transaction hash and event index, which would be 29. You will get the same thing, right? Besides this decoded log as a reference. So you can see topics is in an array format, and we want topics 1, which is the second item in the array, right? Topics array start from 0 as the index and then goes up to 0, 1, 2, 3. So topics 1 will be this over here, which is what we see here, right? If we go back to hex, it's hard to see, but oh, sorry, there you go, right? It's 0 with it's a bunch of zeros, and then it ends with 89, which is the exact same thing as we see here. And how do we decode it? We go back to the data type. Because we know index topic 1 is an unsigned integer, we would just have to apply the hex to integer function. And so I'm gonna add a column called topics 1, and then the hex to integer function is in this live query tab. Go to utilities, hit utils, and there is a UDF called hex to in, right? So just do live query dot is it live? Sorry, utils dot UDF hex to int, and then I'll just cast this as string because there is this quotation marks here, so this just removes the quotation marks. But this would convert this to integer, right? Now I'll run this and call this as destination chain ID. So destination chain ID, and I'll run this. Now if you want to double check, you can also use other websites like a hex to in website. I always use this website called Rapid Tables. Just paste the hex number here, right? The bunch of zeros followed by 89. Hit convert and gives you 137. And you can look at Etherscan again, change to decode, and it gives you 137. And if we go back to our query, we should also get 137. There you go. Destination chain ID 137. Now, in this context, what exactly is chain ID 137? You would have to read the docs for across protocol. Alright, exactly what is 137. And yeah, so that's basically for int, right? So for integer, just convert from hex to int. Now, what if I want to do an address? And we know here it says index topic 3. Index topic 3 is of data type address, and it's the depositor's address. So how do we do that? So we know it's in topics 3. This is the address. We would just want to remove this leading or trailing leading zeros, and so we would use the substring function. So I'll go back to my query over here, look at topics, which is the last one we want, right? 0, 1, 2, 3, and I would just do substring topics tree, and I only want this portion of, sorry, this portion of topics, right? And I will cut off all this. And usually, not usually, but it is certain that the amount of zeros would be 24. Okay, the portion that I'm highlighting, and so you want to remove the this additional 2 characters here, right? Which is 25, 26, and so you want to start. You only want the 27th character onwards, and so I will just put 27 here. And if I run this, it will just cut and output me this of what I'm highlighting. And because it's an address, I want to add the 0x in front, and so I would do a concatenation function, which would just be like this. You can also do 0x concat this, but this works. So unknown function, guys, cause I typo. It's supposed to be sub str, not sus. And yeah, the result is cutting all the zeros in the front and just putting 0x 1 2 3. Now if we look on Etherscan, there is no option to change as address over here, but you can imagine if it's 0x in front, it will just be 0x 1 2 3. So there you go. So those are the 2 main data types that you will encounter, right? Amount, hex to int, address, use substring and remove the zeros in front. Now the second most common that you encounter are tuples, which are right here, right? There's another event index called tuple. Now tuple just means it's an array that can store different data types, right? It doesn't have to be the same type. So for example, you can have address, integer, so on and so forth. And so when it comes to tuple, there is something unique that you need to take into consideration, and that is it has like a set of rules you need to follow. But once you follow that rules, because the underlying things that are stored in the tuple are still addresses and integers, you apply the same addresses and integers decoding methods, right, of the hex conversion and also the substring conversions. Now I just recalled there's one more thing I want to talk about, which is timestamp, right? And let's try to get this timestamp. So it's in data field, so I will go to our data field. Right, it's this bunch of hex data, and there is a very nice regex line you can use, which basically says take off the first 2 characters, right? This 0x, I don't need this, and then chunk it up into 64 characters long, and then store them as arrays. And so you look like this, where we can now, let's say we want to get the first element, we can just do segmented data 0, and we will get the first element. Now this is very convenient because now we can go back to Etherscan and identify which position is the timestamp in. In this case, it's the 4th position, so it will be segmented data and then in parentheses 3 to get this 4th in the 4th position, I guess, item, and then we'll see how that goes. So first, I want to do segmented data 3 because it's the 4th item, and it's an integer, so I'll apply the hex to int thing. So hex to int, all this, and I'll call this as like what do they call it? They call it quote timestamp. Okay, quote timestamp. That's right. Okay. So we would see that it's a timestamp in integer format, right? How do you want to make it into timestamp? You just use the toTimestamp function. So Snowflake has this really cool function called toTimestamp, and it converts a timestamp that is in Unix format to an actual timestamp in UTC. So if I run this function, I should get a nice timestamp data. So there you go. I've got the Unix version, right? And then the timestamp version, which is 3rd February, 4:55 a.m. UTC. Okay, so follow these rules and you should be able to decode all the basic addresses and integer data types. Now let's move on to tuples, which I started earlier. So for tuples, I would use cport as an example, because it's one of the most, it's one of the more complicated tuples because there's two in the same event. And it's a good example because I can then talk about how, the rules that we have to follow when we deal with tuples. So the first thing to do is actually to go to this contract. So because I'm using cport, you just click on cport. It takes you to the contract page, right? You click on contract. You click on the contract tab, and you would scroll all the way down to the ABI function, right? Contract ABI. Hit copy. Go to this website called codebeautify.org/JSON viewer. Paste your ABI on the left, and you would see that it's all formatted nicely on the right. And we will then search the event name. How do we get the event name? We go back to our Etherscan and see that it's this name over here called order fulfilled. Copy that, paste it here, and we're looking for order fulfilled event. And this is the exact part of the ABI that we would need for decoding. Okay, so I'm just going to run through what this looks like. Now, the name of the event is located at the end of the section, so you have to scroll up a bit. Notice how here it says 49. So I'm going to scroll up to where it says 48. And 48 will be the start of our order fulfilled event ABI, right? Which just tells us what are all the inputs in the event that is emitted. So first we see order hash, right? I'm just reading the names that are given for the inputs. So order hash, offerer, zone, recipient, and then here is our tuple, right, called offer. So again, order hash, offerer, zone. I'm going back to Etherscan. Yeah, this one. See how there's also order hash, offerer, zone, recipient, and then offer and consideration, which are both of tuple data types. Right. So byte32 really it's just it's like an address, so you just remove the zeros up front and you will get the address. Zone is of data type address, so exactly the same thing. Right, remove the zeros. And then now we get to what is in data, which is first order hash, and then second is the recipient, and then offer and consideration, right? Because in topics there's already offerer and zone, right? It says here index topic 1, index topic 2, offer and zone. So all that is in data would be then order hash, recipient, offer and consideration. So those are the, I guess, 4 things, and it goes in those exact order, right? So the first the first thing you would have is the order hash. And is this hex data where, yeah, it's just order hash. Don't have to do anything about this. The next data is recipient. We know it's of address. Its data type is address. So hex format looks like this. Just remove this bunch of zeros up front, and you would get this nice address over here. And now is where the tuple data starts, right? Because we've just passed order hash and recipient. And so all this from here to here are the two tuples, which are offer and consideration. Now, the thing about tuples you need to know is there are, I guess, two rules to apply. The first rule is the start will always tell you, so let's say there are, in this case, there are two tuples, right? Offer and consideration. And that means there will always be two lines that tell you each where the starting point of the tuples, where the starting point of the tuples is, right? So let's say the first tuple offer, it starts at this number, right? And then consideration tuple starts at this number. So okay, so that's rule number one. It always tells you where it starts. Okay, now then we go into expanding rule number one. What exactly is this number, right? Well, as you can imagine, it all starts as a hex number, right? Hex data. Convert this into an integer, right? There's a cool function here where Etherscan allows me to just click on number. It converts into a number. So somehow these two numbers tell us where offer and consideration tuples respectively begins, right? And what exactly is this number? This number is the amount of bytes that are used as buffer. And what I mean by that is, so each line over here is 64 characters long, or 32 bytes. Okay, I guess 32 bytes. And so 1 to 8 tells us there is 128 bytes used before the start of the offer tuple. And so another way to think about it is you just take this number over here after you've decoded from hex to int, divide this by 32, and you will get 4. Okay, which means the offer tuple starts after the 4th line. So 1, 2, 3, 4. Here now starts the tuple offer. Here begins the offer part of the event. 288 divided by 32 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Lines after the 9th line, this number 3 over here is the beginning of the consideration tuple, right? So from here all the way to the end, all these are under consideration. And then from 1 to 1 over here, right, these 5 lines, all these 5 lines belongs to the offer tuple. Okay, so rule number 1 again, it always tells you where is the line essentially, right? Where does it begin? Okay, and so that's rule number 1. Rule number 2 is then it tells you the start of the line, tells you how many arrays are there. Okay, so the start of, so again 1 to 8 divided by 32 is 4, so we skip the four lines. Here is the beginning of our offer tuple. And rule number 2 says that it tells you how many arrays are in the tuple, or are in this offer part. And so it says 1, and we get 1 because it's a hex data as usual. We would convert this to hex to int, and we will get 1. And 1 means, there's only 1. So the next line would then have only one set of offer. Now, what exactly is offer? Which is this tuple over here. Offer, then this is where we will go back to our ABI again. Now, recall earlier how we have order hash, offer, zone. All these are in topics and the first part of data, right? Non-tuple, so you can just access this directly. And this is our first tuple, which is offer. Now, notice how there's like 4 things here, right? 4 components. Item type, token, identifier, amount. And these 4, one array would have all these 4 information. Okay, so if there are 2 arrays, there will be 8 lines, right? One array would have 4 lines. So we go back to our data. Where is it? We would see that so this is the beginning. It tells us one array. We will see that it only has 4 lines of data, which is this 3, address, 2, and 1, right? This 3 over here, if you recall earlier, is the start of consideration. It's not related to the offer tuple anymore, right? So this 3 actually is, or the names of these 3 variables are actually what is recorded in the API, which is item type, token, identifier, and amount. So first one is item type. So 3 here would then be item type. Number 2 is token. We see is of type address. So this is the token address, right? The next one is identifier. It's an integer. So number 2 as an identifier, and amount is 1 as an integer. Now you would have to look into the cport contract as to what these numbers mean, like 3, 2, 1, right? But for context, I'll tell you right now. So item 3 just means it's ERC721 NFT, non-fungible, right? Identifier means wait, what? Token identifier amount. I actually forgot what identifier means. I thought it's the I know amount is the quantity, like how many of it. So if it's an ERC 721, amount is always 1. But I forgot what identifier is supposed to represent. So yeah, that's why you need to go through the cport contract. It says somewhere over there. But anyways, this is how you tie it back, right, from the ABI back to Etherscan, right? Again, let's go through it from top to bottom. The first 2 is not related because here is order hash, right? It's directly, we can use it directly. Order hash, and then address, recipient. And then rule number 1, it first always tells us where exactly the position of the tuples. 128 means 4. 288 divided by 32 is 9. So the offer tuple starts after the 4th line. So 1, 2, 3, 4. And this one, the second rule states that it always tells us how many arrays are there. In this case, there's 1 array. And so 1 array, then the next line would begin the contents of the first array. How do we know how much contents there are? We go back to the ABI to see offer. And it tells us there are just 4 things in offer, which are this item type, token, identifier, amount. And that's how we get, that's how we know these 4 things relates back to the ABI. And 3 is the start of consideration. And 3 tells us that there are 3 items, 3 items in each array. Oh, sorry, there are 3 arrays, okay? How do we know what items are in the array? We go back to ABI, look for the next one, which is called consideration. In this case, there are now 5, right? 1, 2, 3, 4, 5, right? Item type, token, identifier, amount, and recipient. And so each array would contain 5 rows. So we go back to the data. Right, 1, 2, 3, 4, 5. This is 1. Okay. 1, 2, 3, 4, 5. This is another. And 1, 2, 3, 4, 5. This is the last array. So in the consideration, it has 3 arrays. Each array has 5 lines of variables. And so in total, this would have 15 lines of variables. And yeah, decoding each manually each of the individual items in the array follow the exact same principles as your address integer rules, right? The hex to int conversion, the substring conversion. So yeah, that's about it. That's a quick overview of how you can decode event logs manually. Let me know if you have any questions. And I guess thanks for watching. See you on the next one.